All right, here's a fun one. Number 6. So prove that the sum of the exterior angles of a triangle is 360 degrees. Right, and this is something that you'll learn later on that that this is not only true, that you're going to prove that here in a second. Not only true, but something that you'll notice is uh, common among other polygons as well. Okay, so I don't want to, without giving you too many spoilers, I'll just leave it at that. Okay, so anyway, so we're talking about exterior angles, right? So what are the exterior angles in this triangle? And I'll be a little more broad with this one. So try to figure out a relationship with the exterior angles here, and there should be 3 exterior angles that are labeled or numbered, and then try to find a relationship with those and the interior angles, right? And hopefully those are pretty obvious. So find relationships with each set of with each exterior angle and some interior angles. Find a relationship with all the interior angles, right? Remember what we know something about the measures, the sum of the measures of the interior angles of a triangle, right? And then you're going to use some substitution and even some subtraction and things like that to make the relationship to say that those angles are that they add up to 360 degrees. Okay, so I'm gonna kind of leave it at that with this one. I know it's a little more vague than some of the other ones. As far as starting out, we're not really given anything. You could say, given triangle ABC or something like that, right? And you could just say given because we're given that in the picture. But and that's just to say that, okay, well, the sum of the angles of a triangle add up to blank and so forth and so on. So all right, so use the sum of the angles of a triangle theorem, and use the exterior angle theorem. Okay, triangle exterior angle theorem, and the triangle angle sum theorem. Number 7. So finally, we have a pretty straightforward one. This one, as far as I can see, there's really one statement that kind of connects everything, but you do have to use some congruence because remember that, or some definitions of congruence, I should say, because remember that here we have measures of angles, right? So at some point, because we're given parallel lines, we're probably going to use alternate interior, alternate exterior, things like that, right? And those tell us congruent. So like we might be able to say that angle blank is congruent to angle blank, but then we have to say that that their measures are equal by the definition of congruence, and then we can use maybe some transitive property or substitution to say that one is equal to a measure, a certain specific measure, maybe 65. Okay. All right. So anyway, so that's that one. I think it's pretty straightforward if you know what to do when you have 2 lines that are parallel to the same line, what happens there, and then use some congruence definitions or some definitions of congruence, and then maybe some substitution or transitive property. All right, so here's the one number 8, where if this is on a test, if this is on a test, let's say, or on an assignment, I'd want you to explain a little bit here. That wouldn't necessarily go into your proof, but it'd be something that you could show me in the diagram or explain in words if it was digital and you can't show me in the diagram. Okay, so here we're given that AB is parallel to CD, right? And we want to prove that the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2. Okay. So basically, we don't really have a connection between these angles because the transversals don't connect, right? So these lines kind of stop short of connecting to both parallel lines. So we don't really have the transversal just yet, right? So that's why we need to extend one of these lines, right? So we can extend GF, okay? And remember, that's called an auxiliary line when we extend or make another line. And so basically we just continue that line on, or you can do the same thing with EF. You can actually do this either way. Okay, so once you do that, you have a triangle here, right? And you can label this angle like 5, for example. And remember, you can make a triangle this way too, and do the same thing with EF if you want to be a little different than the way I'm doing it here. Okay, so then we have an exterior angle, we have 2 remote interior angles, we have vertical pairs, we have now we have a transversal that crosses 2 lines, so we can say something about angle 2 in one of those angles in the triangle. And so so there's a lot of ways we can go with this. And don't forget to use your definition of congruence to go from the alternate interior, vertical pairs, and things like that, and knowing that things are congruent to the measures of them are equal. You'll have to do that because you want to get down to measures at some point, and you'll use substitution I think it's substitution and maybe some subtraction on this one. No, I think it's just substitution or transitive property. So, all right, good luck. Let me know if you have any other questions. Keep working hard.